My name's Colin Sullivan. I'm a principal engineer on the NATS team, full-time. I've got many years experience in messaging from TIBCO Software and Tellurian before then. I've been working on NATS for about 2 years, and I just have to say NATS is it's a really cool product to work on. So today we'll be talking about monitoring, but before we dive into that, for those of you that may be relatively new to NATS, I'll just cover some background. So what is NATS? NATS is messaging made for developers who want to spend more time developing applications, more time in their area of expertise than worrying about a messaging system. So NATS is high performance, it's always on and available, extremely lightweight, extremely easy to use. It has at most once or at least once delivery, providing different qualities of service. Your common message pattern support. So this is your pub sub, request reply, distributed queue, and NATS is cloud native. It was built from the ground up to work in the cloud, so there's a lot of cloud-friendly features. NATS was created by Derek Collison. He's the founder and CEO at Apsera. Apsera officially supports NATS. He's a CTO. He was the CTO and chief architect at VMware. He architected Cloud Foundry, was a technical director at Google, and SVP and chief architect at TIBCO. Derek's been building messaging systems and solutions for over 20 years. He's one of the guys that have been solving the really hard problems in the industry. So he built NATS, and around NATS hired a highly experienced messaging team with people from TIBCO, Tellurian. We recently have Tyler from Workiva, and just a really top-notch team. We also have a very engaged user community, which is one of the strengths of NATS. A while back, we had a user discover in the fast path to the NATS server an additional mem copy. And it was really a one-line change, but it bought us 2 million messages a second. And this had been unnoticed for years. So it's amazing how some of our users can really contribute and just make NATS a really solid product. So what's in NATS DNA? Well, performance is king. You're going to be hard pressed to find a better performing messaging system. It's really simple. The server is a single binary with no external dependencies, making it very easy to deploy. DevOps love us for that. It has a text-based protocol and many client languages. So it's easy to develop clients for NATS. NATS provides availability over anything. So it's designed to always be there. And NATS has a small footprint and is very embeddable. What this all boils down to is NATS is just what you need and none of what you don't. Some of the ways NATS is being used by developers include IoT messaging. One of my favorite use cases is a circular world where NATS is on people's cell phones or an application is on people's cell phones, and it uses NATS that when it detects too much vibration, sends a NATS message to a central server, and it serves as an early warning earthquake detection system. It's a really cool use case. We have high fan-out messaging, for example, Greta.io, mobile and big data with clarified microservices transport. Netlify uses us for that. We have service discovery, and of course, we can replace legacy messaging systems as well. We also have NATS streaming, which provides the quality of service that you may need beyond NATS. NATS in itself is you send a message and it may or may not get there. Usually it will, but it's up to the application to make sure. We realized that people needed more of a guarantee, a better quality of service than that in some cases. So we provided NATS streaming, and it's a data streaming system powered by NATS. It has at least once delivery. Rate matching per subscriber. You can replay historical data, give me the last hour's worth of data. Or it can be a last value cache. You have durable subscribers where you create a subscriber. If there's an interruption in service and then service returns, it'll pick up where it left off and receive all the messages that were sent while it was away. You have fault tolerant configurations and partitioning for scalability. So let's move on and talk about monitoring NATS. Monitoring NATS servers is pretty simple. Each server is monitored independently. You enable a monitor port to the command line or configurations file for the server, and when you enable a monitor port, that's when the NATS server actually enables its monitoring systems to handle polling. You pull an endpoint for metrics. So you can pull VARs, which is really your miscellaneous information, cons, connection-related information, subscription-related information, and routes, which is more internal to a NATS cluster, which would be information related to how the cluster is performing. And this is really pretty simple, but this simplicity allows you to build complex tooling on top of it, which, adhering to the tenet of NATS simplicity, really tends to work well. NATS server monitoring data is served up as JSON formatted data. Most newer languages natively support JSON. So, it's a well-defined standard and it seems to work. One of the things we built in-house, Wally built NATSTop, which is this really cool monitoring system for the dev guys that love to just get on a box. Let me see what's going on with this one NATS server. And it's very straightforward, to the point. You can see your connections and everything. And for those Unix guys that just love Top, this will be very familiar to you. We also have a user-contributed NATS monitoring system with NATSBoard. This was in JavaScript, and it pulls the NATS server, which then serves up this JSON data, and it presents this in a very nice format. So you can see from the same background data, you can really present monitoring information in a number of different ways. One of the things we recently completed is the NATS Prometheus exporter, which is a Prometheus exporter that pulls data from the NATS server and presents it in a way that Prometheus understands. I'll show you how to use the Prometheus exporter with Grafana to view what's going on with NATS. So here's the general architecture. You have the NATS server. Each one's paired with the NATS Prometheus exporter. And that's a recommended configuration by Prometheus. Prometheus server will then scrape the NATS Prometheus exporter for data, aggregate it, and then Grafana can grab this data from Prometheus and display it very nicely in a dashboard, however you want to set it up. And you access that through your browser. So how do we set this up? Well, first, you need to configure your NATS Prometheus exporter. As I mentioned before, you just have to simply ensure each NATS server is using a monitoring port. You do this through the command line with a simple flag or through a configuration file. And then you start an instance of the NATS Prometheus exporter for each NATS server, preferably paired right alongside it. This is the Prometheus recommended configuration. The default exporter port is 7777, and you can change that, set via command line parameter. And really what you do is you just launch the NATS Prometheus exporter. You indicate what endpoints you want to listen to. In this example, I only want to listen to VARs. I can also specify subs and cons. And then you give it the URL of the NATS monitoring URL served by the NATS server for monitoring information. In this case, on port 8222 on the local host. Next, you have to configure Prometheus. And we'll go with the minimal configuration here, just to keep things simple. The minimal configuration is to simply add targets to the Prometheus configuration file for each NATS exporter. So you do this by just adding targets in the static config. At this point, you can do additional relabeling and rules in Prometheus. And then you can also configure alerting rules and set up the Prometheus Alert Manager. So if you have any error conditions you want to monitor for and be alerted by, this is where you can set that up. Next, you configure Grafana. So you set up Grafana, install it, add authorization as necessary, and then you set up the Prometheus data source. In this case, it is localhost 9090. 9090 is the default port for Prometheus, but that would really depend on your environment. And then what you do is you can import the NATS dashboard. You can build your own, or you can import it. We've got a Grafana NATS dash JSON in our Prometheus NATS exporter repository. We've also put it up on Grafana, so you can download it directly from Grafana. Then what you do is associate the Prometheus data source with the dashboard, and then start monitoring. And the Grafana default is localhost 3000. At that point, you'll have a dashboard and see something similar to this. So let me run through a quick demonstration walkthrough of this. So first, I'm going to walk through what the demo looks like. So some basic cleanup here. And if you remember, the Prometheus exporter paired with the NATS server, I'm going to start the NATS server monitoring on port 8222. Let me make this a little bigger for users. And then the client will run on port 5222. And this is really just so I'm going to run a benchmark against it so you can actually see something happening when we're monitoring. And here, the Prometheus exporters listening or scraping the server at 8222. And we're exposing port 7777 for the Prometheus server to target this exporter. We're going to do the same with the second set of NAT servers. In this case, just incrementing by one port. You can see 8223, 8223. I'm going to allow Prometheus to scrape on 7778. Then we're going to launch Prometheus. Prometheus will read its configuration file here, and we set up various parameters. This one is super simple, and here are the targets it's going to scrape. So going back to the demo here, you see localhost 7777, localhost 7778. Right here, these are where I'm allowing the NATS exporter to serve up data from the scrapes from the Prometheus exporter. And then next, we'll launch Grafana. This is really Grafana installed with the default settings. You configure Grafana to talk to Prometheus from within the UI. So let's run our script. And it all started. We've got a pair of NAT server and exporter, a second pair, Prometheus, and the Grafana server. So what we'll do is let's take a look, and let's start from the bottom up and hit the NAT server to look at the monitoring data it's going to provide. So we're going to go to the NAT server here. This page is served up by the NAT server. It's as convenience. And what we're going to be interested in for this demo is bars. Here's your JSON data I was talking about earlier. Very easy to parse, well-defined standard. You can actually kind of read it, which is a little nice, fairly nice. And what we're going to do next is let's take a look at the Prometheus exporter paired with the NAT server. And this is data returned from the Prometheus exporter. So here is the original data from the NAT server, and it's converted into this by the exporter, which is something Prometheus can understand. Now let's look at Prometheus itself. You can see here the server's running. Let's take a look at the targets. Here are our two NATS Prometheus exporters. It looks like they're up and running. They were scraped fairly recently. And finally, let's take a look at Grafana. So here's Grafana. In this case, I've already installed the dashboard, but let me first go back and I'll show you the data source. So here's the NATS data source I've configured. And I welcome you to go through the walkthrough we have on our repo, which shows you how to do this. Localhost 9090, which is the default, and you can see that it's working there. And now let's go to the NAT server dashboard. So here's our dashboard. You can see a few minutes ago, we started up the NAT server. And it started up, and as it's spinning up, it just creates, it allocated some memory here. You can see we've got no bytes or messages in, no bytes or messages out. I added this just for this demo. I'm going to probably tweak it and check it in later this week, which is message rates. And then there's connections, subscriptions, and slow consumers. So some client metrics of things related to the client. Now, let's take a look at the benchmarks we're going to run. So I'm going to run NATS Bench, which is installed with the NATS Golang client. And I've simply built it, and I'm going to run it here, pointing to the 2 servers that we have. This one's going to have 2 publishers, 4 subscribers. I'm going to put 10 million messages through it on subject foo. I'm going to do the same with the second server, except with 3 publishers, 1 subscriber. I'm going to do 20 million messages. So let's run our benchmarks, and then we'll take a look and see what's happening here. So you can see here the server's starting to allocate memory. We've got about 10, 11 meg, which isn't bad for 20 million messages. You can see that we're counting the messages in, right? About 10 million last sample, about 40 million out. And here's our byte rates, or the message rates. Yeah, a little over 3 million messages a second, which isn't bad for my old MacBook Pro while doing a webinar. And it looks like the benchmarks have about completed. And then here you can see that you've had 6 connections during this period of time on server at 8222. And then if I switch to this one, you can see I had 4 connections on server 8223 during this period of time. Same with subscriptions, I can look at that data. And slow consumers, in case you have some consumers that aren't keeping up. Looks like we did fairly well during the demo here. And that really sums it up. So this is what the benchmark looks like. This is what the benchmark looks like in Grafana, looking at our dashboard. And let me just return to the slides here. And I just want to thank everyone for listening. And I'd like to open things up for questions.
Excellent. Thanks, Colin. I did see quite a few questions come in while you were stepping through that. So I'm going to start going through those, and then if any others come up for anybody that's listening, if you want to know anything, just go ahead and type them into the question box there. So we'll get through as many as we can. The first question that came in, Colin, someone was just asking if we've published any pre-set up NATS streaming plus Prometheus and Grafana Docker images to allow people to play with this setup pretty easily. They said they realize it's not that complex, but that being said, if there's a Docker image, they'd love to know about it.
Yeah, we haven't at this point. The Prometheus exporter is still in beta, and what we can do is after we get a little bit more feedback from the community, we've already had some great feedback, by the way. Once we get to the first release, that would probably be the time we'll create a Docker image. And I agree, that is a great idea and will make things super simple.
Okay, great.
That's something we'll plan to do in the future.
Good. The next question I saw, someone was just asking about, saw the benchmarks. Are there any limits or dependencies that we should know about that you might have run into during testing? And if so, what are they?
Really, none that really come to mind. It was all fairly simple to set up. And during testing of the Grafana and Prometheus server, it was, quite frankly, it was very straightforward to get things set up and running.
Okay.
That being said, if anyone runs into any, I would absolutely love to find out, and we'll add that to the walkthrough to make things as simple as we can for our users.
All right. The next question that came in was a bit more generic, not quite related to monitoring, but someone had said they noticed you also maintain the .NET client, and they were wondering what some of the recent and upcoming updates you might be planning to make there are, because they're a Windows shop.
Okay. I'm changing gears. Yeah, we're bringing the .NET client up to speed with the Go client. There's been some newer additions to the Go client, so we're going to be bringing .NET client up to speed there. Basically adding a callback for when new servers are added to a cluster. The clients are now notified, so users will be able to add an event listener to that and be notified of that. And then also we're going to be adding request reply enhancements, which will, I believe a user's contributing this right now, which should really improve performance with request reply. Those are the two things off the top of my head.
Great. Let me see here. One more question just came in. All right. The other question here was related to connectors. So similarly, and it's okay if it's off the top of your head, but they were just wondering if there was another connector or two that you plan to do next. They said, the person asking this question said that seeing and visualizing it helped a lot, and was excited to just hear about maybe potential connectors we're going to do as a follow-up. Well,
yeah, we really would like to get more input on what people really want to see with upcoming connectors. We've discussed some things such as a Kafka connector, MQTT connector, maybe something with gRPC and NATS. We'd love to hear. We'd love to hear what people want to see and what people really need.
Yeah, exactly. And related to that, I would just encourage the person who asked it, as well as anybody who may be having similar questions. If you're not already in our Slack community, it's a great resource for that. So just request an invite off of our community page. It's nats.io/community. We'll get you in there usually the same day. And then on top of that, Google Groups is good as well. We monitor that. But to the extent possible, yeah, as Colin said, we'd love to hear any feedback. If there's a particular use case you have for NATS where you think a connector would make sense, the more you can share with us about that, the better that we can sort of prioritize where we're going next. So I didn't see any other questions come in. Oh, hang on. One did. Let's see, last question. So okay, actually the question that came in is related to clustering. So I will follow up directly with that person. I see that, and I know the response to that, but it was related to NATS streaming clustering. So I'll reach out directly to the person that asked that. I didn't see any other questions that were related directly to Prometheus monitoring. So I think with that, I'd like to conclude the webinar and say thanks to everybody who joined. Appreciate all the questions and taking the time to share some of the feedback as well. And then, as Colin said, we would love to hear ongoing feedback or questions as you have them. So find us in Slack, find us via Twitter, Google Group. And as I said, I will send a recording out later this week to everybody that RSVP'd, and the slides as well. So thanks again, and we will be looking to do another webinar in the near future. So we'll make sure to update you on that as well once we have the topic.
All right, thank you, everybody.